All right, section 5.3 is on angle bisectors of triangles. And the question we're going to answer is, what is special about angle bisectors? All right, one definition, the incenter is the point of concurrency of the three angle bisectors of a triangle. All right, and we have a couple theorems. Theorem 5.5 says, if a point is on the bisector of an angle, then it is equidistant from the two sides of the angle. So in the picture, if segment A or ray AD bisects angle BAC and DB is perpendicular to AB. So if this is perpendicular and if DC is perpendicular, then DB is equal to DC. Okay, and the reason why they talk about being perpendicular is because when we're talking about distance between two things, the distance between two things is always a perpendicular line. Right, the shortest distance is a straight line right to it, which would be perpendicular. So you can see that point D is on the angle bisector. The angle bisector is this blue ray. So then those two red lines are going to be equal to each other. That's what this theorem says. Theorem 5.6 is the converse of the theorem we just covered. If a point is in the interior of an angle and is equidistant from the sides, then it lies on the bisector of the angle. So if DB is perpendicular to ray AB and segment DC is perpendicular to ray AC and DB is equal to DC, so you can see that this red line and this red line are equal, then ray AD bisects angle BAC. So basically, if it's on the angle bisector, it's equidistant from the sides, and if it's equidistant from the sides, then it must be on the angle bisector. So example 1 says, find the measure of angle CBD. So you can see that these two segments are both 21, so they are congruent. Since they are congruent and E is on this line, since they're congruent, this line, this blue line, is an angle bisector. Because the two red distances, the distance from the two sides of the angle are congruent. So therefore, ray BE is an angle bisector. So that would mean that the measure of angle CBE is equal to 31 degrees because these two angles have to be the same. Okay. Example 2 is the spider web example. All right. A spider's position on its web relative to an approaching fly and the opposite sides of the web forms congruent angles as shown. So I know you can't see everything here because it's kind of covered up, but this angle and this angle are congruent. So there's this blue angle, and since those two smaller angles are congruent, that means that red line is a angle bisector. So will the spider have to move further to reach a fly toward the right edge or toward the left edge? So the spider is right here in the middle. Is it further to go on the green line or to go on the yellow line? Okay, and the answer is, since the spider is on the angle bisector, it is the same distance to either side. So it's the same distance either way. Okay, our next example, I'm going to redraw this or kind of finish drawing it. So we should have is an angle that looks like this. This is called P, and then this is 2x minus 5. I think you have this on your paper, or hopefully you do. This is L, point L. This is point J. So this picture goes with example 3. It says, for what value of x does P lie on the angle bisector? So if P is on the angle bisector, that means that these angles would be equal. And if those two angles are equal, that means these two blue segments would be equal. So to lie on the angle bisector, x plus 1 would have to equal 2x minus 5. We would solve this. So to solve this, you'd minus x. To get 1 equals x minus 5. And then to get x alone, you would have to add 5. And you'd end up with x equals 6. So x would equal 6 for this one. Or if x is 6, that means that P would be on the angle bisector. Our next theorem talks about concurrency. The angle bisectors of a triangle intersect at a point that is equidistant from the sides of the triangle. So it says, if segment AP, segment BP, and segment CP are angle bisectors. So if these three blue lines are angle bisectors, then P is the same distance from the sides. So we'd say, therefore, PD is equal to segment PE, and that's equal to segment PF. So the point where the angle bisectors cross is the same distance to all the sides. So in example 4, it says, in the diagram, L is the in-center. The in-center is where all of the angle bisectors cross. So all of the angle bisectors cross at a point that is equidistant from the three sides. So since L is the in-center, it is the same distance for all those red lines. Okay, we want to find the length of LK. So if we want to find the length of LK, we'll call this part X. So if that part is X, then all of these red lines we can call X. Okay, they're all X because they're all equal to each other. So what we can do now is we can take this triangle right here. This is a right triangle because of that's got to be 90 degrees there. So I'm going to take that triangle, I'm going to redraw it. It's a right triangle. We have 15, we have 12, and we have x. And we're going to solve this triangle for x. To solve for x, we would have to do Pythagorean theorem. So Pythagorean theorem is a squared plus b squared equals c squared. So we have a, b, and c. In this case, c is the side that's opposite the right angle. So here's the right angle. Opposite the right angle is c. So this would be x squared plus 12 squared equals 15 squared, which would be x squared plus 144 equals 225. Okay, and then to solve for x, we would have to get rid of the plus 144, which would be minus 144. So x squared equals 81. And then get rid of the squared. So to solve for x, we do the square root. So x would equal 9. So that means that LK would equal 9. Because all those red lines on the right are the same, so all those red segments would equal 9. Okay, let me have a couple checkpoints. Checkpoint 1, find the value of x. So we can see that these two segments are congruent. So if those two segments are congruent, and you see that they're perpendicular to the sides of the angle, which means that this is an angle bisector. So that means that 3x minus 5 has to equal 2x plus 5. Because the angle bisector would mean that it cuts the angle in 2 equal parts. So we would get all of the x's over to the same side by subtracting 2x. So x minus 5 equals 5. And then to cancel out the minus 5 on the left, we would add 5. So x would equal 10. In the second example, these marks by the angle would indicate that this is an angle bisector. And if it's an angle bisector, the distance to the sides of the angle are equal to each other. So 7x plus 3 has to equal 8x. So then you would subtract 3 to get 7x. Actually, excuse me, I am wrong there. Subtracting 3 is okay, but it would be longer that way. Well, the easiest way would be is to get all the x's together, so we would subtract 7x. Because the x's cancel, and we end up with 3 equals 8x minus 7x is just x. So we would get x equals 3. There, that's much faster than if we would have subtracted 3. And then example 3 says, do you have enough information to conclude that ray AC bisects angle DAB? Explain. So we're looking, is this an angle bisector? If it's an angle bisector, these two segments would have to be congruent. So those two segments are congruent, but what we're missing is, if I zoom in, these angles right here are both equal to each other, but we do not know that they're right angles. So is there enough information? No, we don't know that angle ABC and angle ADC are right angles. And the right angle part's important because the right angle will mean that that's the distance to the side. So we don't know if these lines right here, this line and this line, are actually the distance to the side. So that's why we can't say that those are necessarily a perpendicular bisector or an angle bisector. Okay, and then I'm going to skip example 4 for right now. What we have covered is where we'll stop. And that's what we got for today.